Hi, this is exercise 10H for Year 12 mathematicians. It's basically building on what we've done before on trigonometric identities and also how to solve equations. And basically what we're going to try to do is use two trigonometric identities to solve equations, which otherwise we wouldn't be able to solve. So let's crack on with this. Or better set the pen and stuff. I always forget this until it's too late. Pen, there we go. So hopefully that will now work. Yes, it does. So two trig identities that we've seen before. This is the first one, cos squared x plus sine squared x equals 1. And we saw that a couple of PowerPoints ago. Just be aware that on this side, you could easily move the cos squared onto the other side and get an equation which says sine squared equals. Alternatively, you move the sine squared over and you get an equation saying cos squared equals. And in fact, this is what we do. And these two resulting rearrangements are incredibly useful in a variety of contexts, but particularly what we're doing here today, where we're solving trigonometric equations. Very often you need to do this. And of course, there is the other identity that we've seen before as well, tan theta equals sine theta over cos theta. There'll be a number of times we're going to use that to solve equations as well. So let's have a look at our first one. Yeah, just a reminder, you can use these to solve equations. So this is our first one. It's in degrees. It says 0 to 360. And our equation says 2 sine squared theta minus cos theta plus 1. So the very first thing you notice is it says sine squared theta here and cos theta here. And it's this reason that we need to use one of our identities. If it said cos squared, we saw quite a few of those examples the other day where it said cos squared minus cos plus a number, and that we can do. Or if it said sine squared minus or plus so many sines and a number equal 0, that we can do that as well. It's the fact that it says two different things. Now the problem is cos theta we can't do anything much about. But the sine squared we can do something about. And of course, up here I said that sine squared equals 1 minus cos squared. Now that is essentially what we're going to use. So rather than this, I'm going to write two lots of 1 minus cos squared. And you're going to have to learn these rearrangements. They are so useful. So just writing out the rest of the equation, minus cos theta plus 1 equals 0, multiply out the brackets, 2 minus 2 cos squared theta minus cos theta plus 1. Now if it was me doing this, I'd make everything positive on the other side. I know a lot of you don't bother, you just write minus 2 cos squared theta, because you've got the calculators now, to be honest. It's fine, you don't need to worry too much. Minus cos theta. The only thing I need to worry about is that 2 plus 1, that's plus 3, equals 0. So you go on your Casio ClassWiz calculator. You select the polynomial equation solver, and I'm going to type in minus 2x squared. Notice I said x squared. Obviously I know it's not x squared, but I use the polynomial equation solver just to do it for me. So minus 2x squared minus x, so minus 1x plus 3 at the end, and then I press go. So it tells me what, obviously my calculator, when I do all this, my calculator says x1 equals 1, but I don't care about that. I'm going to write cos theta equals 1. If I press equals again, I get x2 equals minus 3 over 2. That's what my calculator says, but none of this matters. What matters is I get two solutions, one for cos theta equals to 1 and one for cos theta equals minus 3 over 2. Now in both of these situations I essentially now try to solve it. So I move the cos over and I get theta is the inverse cos of 1. Over here I suppose I get theta is the inverse cos of minus 3 over 2, but then the bracket is a bit more complicated. Now first thing, if you type this in, you'll get an error. It will say math error. I'm going to do it now, inverse cos. I need to get out of that. I need to go menu 1 and do inverse cos of minus 3 over 2. And it says on my calculator it's a math error basically. And so as soon as you see that, you know that something's gone wrong. And it hasn't really gone wrong. All that's happened is when you draw a cos graph, cos graphs basically look like that on the left and this on the right. But the critical thing is it goes up to 1 and down to -1. And we're saying, when's this graph hit -1.5, which is obviously what this value is here? And the answer isn't, well, it never does. So we write here no solutions. And you need to just phrase this very carefully, because you need to say, since cos theta is less than 1. Well, technically, it's the magnitude or the modulus of cos theta. That would be the best way to write it. Anyway, even though we've got no solutions there, we do get some here. So if you go I stupidly turned my calculator off, inverse cos of, what was it, 1. And you should know that there are lots of solutions on these, but the principal solution here is the 0 degrees. Now, again, let's remind ourselves what we learned a couple of lessons ago. When you're using coses, and this, I know it started off at sines, but eventually we got to a cos equation. When you've got coses, you get your first solution, theta, and then you do 360 minus theta for your second solution. So my second solution is 360 minus 0, which is just 360. Okay, and that's, according to me, the two solutions. I don't think there's any others. Let's see what I said before. Answers 0 and 360. There you go, down in the bottom right hand corner. I obliterated it a bit, but that's essentially the right answers. So let's have another one. So this is 4 sine theta equals 3 cos theta. Now, unusual, we have not seen many of these, but it's between -180 and 180, so I need to worry about that later on. And I also just need to highlight the fact that there's no sine squared or cos squared, so this is different. This is slightly different approach I need to use here. And the approach comes about, remember I said there were two, that's it. I said there were two identities, and it's this one that I need, the tan theta one. So I just go to that now. How do I get the tan thetas? Well, if you remember, tan theta is sine over cos. And it's a division by cos, which is important. And if I divide both sides by cos, alternatively you can think of that moving over. So if I do that, I get 4 sine theta. Let's think of this as dividing the left hand side by cos, and I'm going to divide the right hand side by cos as well. I'm going to divide both sides by cos. When I do that on this side, they cancel out. And on the sine divided by cos on the left hand side is tan. So I end up with 4 tan theta equals 3. I'll move the 4 over, it becomes times now, it becomes a divide when I move it over. And then finally I can move the tan over and I get inverse tan of 3/4. So inverse tan of 3/4, again on my calculator, inverse tan of 3/4, and it comes up with 36.9 degrees. Okay, theta equals 36.9 degrees. That's my principal solution, but I need the other solutions as well. Now, you may recall that I said for tan, once you get your theta, your next rule, you basically add 180 onto it. And the only problem here is if I add 180 onto it, 36.9 plus 180, so I'm just doing it on the calculator, so it's like 216 here, 216.9. This is too big. This is not in the interval that they've given me. And sometimes you get numbers outside the interval. I've seen one recently where I had to add 360 on to put it in the interval. Sometimes you have to take them off, and that's actually what I'm going to have to do here. 216 is too small, too big rather. So if I take away 360 from it, so I'm just going to write it there. I'm going to take away 360, and I've got minus 143. So I'm just going to write minus 143. It says to 1 dp, so 0.1. So my answer is now 36.9 degrees and minus 143.1. Now we don't get many questions these days where it's between minus 180 and 180, but you can get them, so you just need to be ready for it. So that's that question done. Let's see what the answers were. Yep, that's good. It's always nice to see the right answers. Next question. So this looks in principle very similar to the one we had right at the start. So I've got 6 cos squared theta. Now again, remember what I said. I said that cos squared theta is the one we change, and it can be changed into 1 minus sine squared theta. This is the key. You get cos squared, I'll make it 1 minus sine squared. Why do we do that? Because it says sine in the middle. If it said cos in the middle, we wouldn't have to change it. I could straight off solve it like we've done recently. But it's the different coses and sines that means I have to do these things. So anyway, so from here I'm going to go, well, we've got 6 lots of cos squared, and cos squared is now 1 minus sine squared. So you can see it's very similar to the one we saw before. I think it's the other way round. I think last time we changed sines into coses. Now we're changing coses into sines. I nearly got that wrong. Minus 1 equals 0. Now we multiply out the bracket. 6 minus 6 sine squared minus sine theta minus 1 equals 0. Tidy up, I've got minus 6 sine squared. Notice I always put the squaredy thing first. Minus a sine. And 6 minus 1 is plus 5, so plus 5 equals 0. Again, we need to get you in the right mode, and I'll have to do a menu into the equation mode, and quadratic polynomial, or degree 2, and I'm going to type in minus 6x squared minus 1x plus 5. Of course, although it is x, we know it's not really, so again, let's do the same as I did before. The calculator says x1 is 5 over 6, but we know that means that sine theta is 5 over 6. If I press equals again, I get x2 equals minus 1. Again, the great thing about the calculator is you don't need to worry about quadratics anymore. Now both of these numbers will get solutions because neither of them are above 1 or below minus 1. So if I now inverse this, it's the inverse sine of 5 over 6. So I need to go into menu 1, and certainly no idea what it is. Inverse sine of 5 over 6. It comes up with 56.4 degrees. So theta is 56. Says 3 significant figures, so that's okay. And over here, if I do the inverse sine of minus 1, it's minus 90. Now remember that's not in the interval I want, so I'll have to do that. So I've moved the sign over, I've got that. So on all of these I have to do this. Now it's sine, you remember with sine. You get your theta, and then you do 180 minus theta. It's these rules you've got to learn. So 180 minus the 56.4. Just check it, make sure I don't make a daft mistake at this late stage. I get 123.6. Now it's the 3 sig fig, so that's actually 124 to 3 sig figs. Now the minus 90, I know it's not in the right zone, but I'm still going to do it. It's 180 minus the minus 90, using my 180 minus theta rule, which is 270. And I think that's it. If I add, I think that's it. So let's just see what I got before. Yes, that's right. That's what I got. The 56.4. Was that meant to be some kind of way of showing it, that graph? I'm not convinced by that. But 56.4, 124, and 270. So that's right. This equation, bear with me. Yeah, so I'm sorry, I quickly did this. So you just notice that you've got a bracket times a bracket. So if you get this, one of the brackets must equal 0, or both. So I've written the brackets equal to 0. I've solved each equation, and I've got my principal solution. Then we have to find other solutions. So I've just moved on. I'll quickly do a reminder that with sine you do 180 minus theta, cos 360 minus theta. Now when I do that with the sine I get 210, and when I do that with the theta I get 180. So with both I have to take away 360 because these aren't in the right range, they're the minus 30. So if I do that and I take away the 360, oh, did I see the answer there? Yeah, just about. So they're the answers. This is what you have to do. Best of luck, we're out of time, and email me if there's any problems.